This video, I want to test some of the surprising claims that I saw in the first video. I'm going to try my best to do these things because I don't know for 100% whether they'll work or not. Main thing is I had this normal vector calculation that seemed kind of interesting. It has an x comma y comma z over here in the function notation, but I think z is just f of x comma y. So I think it can be safely left out, but the direction is 1 over, well, it's a vector, and d, well, let's say surface. Let's give a surface. Surf x underscore comma y underscore, and we'll call that colon equals, and then we'll just say that it's, for now we'll just make it x squared minus y squared. Nice little saddle shape. And the vector will be d surf x comma y. Surf x comma y comma x comma d surf x comma y comma y comma -1. And then in the denominator, we'll have square root of 1 plus square root, nope, not squared, d surf x comma y comma x squared, squared, plus d surf x comma y squared. And I want to see if I can plot these things together, so I'm going to create the surface plot separately. That really doesn't need to be there anymore. I've used it. Delete, delete. So just for a little test, I changed the name to normal without an A so that I could change it. Let's see what happens if I put in a 0.1 there. Okay, so it's giving me a different vector depending on where I set my x and y coordinates. Now I need a visual to see what that looks like if I can. And what I'm going to do is I'm going to create a vector that starts at the point, let's see, the point x comma y comma surf of x comma y, and it will end at that exact same point, except it will be plus normal x comma y. And I'll make a little arrow with that and make that part of my graphics 3D, but I also want to call that norm plot equals that, and then I will show, we'll do the surf plot and the norm plot and see what happens. Okay, the arrow is down there, but I want to manipulate it a little bit so we can change the x and y a little around and see if it seems to follow the curve. So for that, I'm just going to change norm plot so that it has an x and a y in it, and this will be x comma y. And then we're going to have a manipulate in here and show that, comma, and we'll have two variables changing, x going from -1 to 1, and y going from -1, 2, 1. Well, I'm still debugging right now, but I do want to change this while I'm thinking about it, because maybe the arrow will be on top if I do that. No, it's not? Really? When nothing changed there, I decided to go ahead and do a clear global so that we get all of the variables cleared at the beginning, because things were acting so strange. I think that the variables aren't working right. Okay, after a little bit of debugging, I've got things so that they're running here. That arrow, I don't know. I don't have confidence that that is a unit vector. I'm not 100% certain that it's staying perpendicular to the surface. Let's see. Let's change the graphing area here so that it goes from, say, -3 to 3, and y goes from -3 to 3. And you know what? Let's see about what is it called? Spherical region? Let's see if that changes anything. It doesn't want that. Maybe if I said spherical region is true. It really doesn't like that, because that should not be a part of a manipulate command. It should be part of a show command. Maybe. Oops, comma. Will that work? Okay, first we got to turn the thing over. Hey, where's my arrow? There's no arrow. Where's the arrow? Okay, the arrow disappeared. Why did the arrow disappear? Okay. Oh, because I stuck this in the wrong spot. Boop. Boop. And then we want this up here. And this down here. Let's see if that fixes it. Okay, there's our arrow. And it just doesn't look right at all, does it? Oh, because it's way over there. Let's see, what's it look like now? Ugh! What in the world? It's way off. It's not pointed the right way at all, it doesn't look like to me. Arrow. It seemed like it was better before, but might be something about what how it's drawing that arrowhead. But it just seems off. Okay, I have just found a function called arclength, which will tell me the length of a line. So if I just put a line in here, because vec xy already has the 2 points, so it's just, I want to have the arc length of the line containing those 2 points. And so this can determine whether that number ever changes when I move it around. No, it does not. So at least we do know that we've got something of a unit vector in there, but it is not staying normal to that curve in any way. There is something wrong with this function here, because I am not sure when the value x and y is being stuck into this function. I actually need it to be like x naught comma y naught, and then this thing is going to do that derivative. And yeah, because we really want to evaluate that thing first and then plug in. Man, I could swear that when I first started, this thing was working great, and now it's just working horribly. It seemed like the arrow was correct when I first started, and now it's just like, no, it's not correct. Okay, I got rid of the arrow now, and I'm just using the points for it. And it looks to me like that is not maintaining perpendicular. That is not the normal to the curve, that equation that the Wikipedia gave. So I'm gonna have to find something else to give that normal, because I'm pretty sure that's not it. Unless it's one of those things that's just supposed to be valid really, really close to there. But if that's the case, well, yeah, I don't think that's a very good, doesn't seem like a very good approximation to me, because that's bending a lot further than normal in my picture. Right, I worked through the problem that I was having, and it turned out that the main problem that I was having was that it wasn't scaled properly. What I needed was box ratios equals, well, I put 2, 2, 2 here, but just any set of even things. What happens without the box ratios there, um, it looks like the x and y coordinates aren't scaled properly, and it ends up looking like that's not perpendicular to the surface. But with the boxed ratios being, I think you can use box ratios equals automatic, and now you can see that the it looks like that pin is perpendicular to the surface now. So I have the pin going all the way through and the surface kind of transparent, so you can see it on both sides now. Now with the saddle form, you get the same thing. The guy stays in the surface there. It's a little bit hard to tell sometimes whether we're in the surface or not with that, though. Let's see. Here we go. Along there. Looks like that's staying pretty well perpendicular to the surface. And thanks for watching.